CamWorks MillTurn module makes programming of complex MillTurn parts easy and can reduce your programming time by 80% or more. This is a model of a complex MillTurn part typical of those used for industrial applications. How long would it take to program this part using your CAM system? CamWorks, the most advanced integrated CAM system available today, runs directly inside SOLIDWORKS, allowing the design and manufacturing models to become one and the same. I'll begin by selecting the CNC machine I want to use for machining this part. Next, I'll define the stock I want to use. The standard coordinate systems for the main and sub spindles have already been created automatically, and just like the stock size, I have the ability to easily change them if required. Now I'm ready to begin programming, and I'll start by running automatic feature recognition to extract the machinable features on the part. In just a few seconds, CamWorks has recognized the machinable features and added them to the feature tree automatically. I'll select the cutoff feature and convert the part off into a facing operation. Next, I can specify I want the facing operation to occur on the sub spindle, and then I'll drag and drop this operation up in the tree before the other turning features. Because the OD and ID will require machining on both the main and sub spindles, I'll specify I want to use both spindles to machine these features. With all my features in place, I now have the power and flexibility to create individual operations for machining or use CamWorks intelligence-based machining to automatically generate the machining operations. CamWorks intelligence-based machining is fully customizable, so you can capture your best machining practices, and CamWorks will automatically generate the operations with the tools, feeds, speeds, and depth of cuts using your best practices. I'll go ahead and use this time-saving feature to generate the operations necessary for the machining. Now that the operations have been generated, I can create the toolpaths. Next, I'll also want to add a sub-spindle operation to transfer the part from the main to the sub-spindle. A library of my common sub-spindle operations appears. Using CamWorks, I can easily create and store sub-spindle operations for later use. I'll select the standard transfer from the list, and I can customize the sub-spindle operation. Here, I'll enter the distance to feed the sub-spindle before gripping the part. Once I've created the transfer I want, I can review it step by step to make sure it's correct, and then add it to the operations tree. Now I'll open the first turn setup and specify I want to use G54 for the work offset on the main spindle. In the same way, I'll also specify I want to use G55 as the work offset for the sub spindle. Next, I'll use CamWorks Toolpath Simulation to review the machining operations and check for any collisions. Using simulation, I can see the turning operations occurring on the main spindle, and also the turning operations occurring on the sub spindle. Once the simulation is complete, I can compare the machined model to the design model. The green color means the machined model exactly matches the design model. The blue indicates there is stock remaining. Here, I can see the wrap pockets have not been machined. Automatic feature recognition is a great automation tool, but building some features requires user interaction. I'll go back to the feature tree and right-click on a setup perpendicular to the through hole to create the wrapped pockets. I'll select the bottom of each of the pockets and then select the surface for the top of the pockets, and then close the dialog box, and all four wrap pockets are added to the feature tree automatically. Notice how even the most complex machining features can be created quickly and easily using CamWorks. Once the features have been created, I can quickly generate the operations and then create the toolpaths using intelligence-based machining. Let's run simulation again, and now we can also see the wrap pockets being machined. First they are rough milled, then finish milled, and the strategy even includes a tool to deburr the top edge of the pockets. Using intelligence-based machining, even complex machining strategies using multiple tools can be stored and reused automatically, saving you time, increasing efficiency, and improving the quality of the finished parts. I'll compare the machined part to the design part again, and now we can see everything colored green, which means the machined model exactly matches the design model, and we're ready to generate G-code for the CNC mill turn center. How long would it take to program this part using your CAM system? Using CamWorks, this part was programmed in just over 5 minutes. I hope you're able to see the power and flexibility CamWorks mill turn offers. For more information, go to www.camworks.com or contact your CamWorks reseller today.